Hello, everybody. Welcome in. Welcome in. If you've been with us before, welcome back. If this is your first time, welcome to the first show. We're going to tell you a little bit how you can go back and watch the others that you may have missed before. But before we do, we're going to do a round of intros. My name is Dash Williams. I am a senior solutions architect here at AWS, and I'm coming to you live and direct from the Houston-ish area, Texas. So while we're doing these round of intros, everybody put where you're coming from in the chat for us so we know where you're watching from. And while we do that, I'm going to go to this guy over here so he can introduce himself.
I think you were pointing at me. I'm pretty sure. Hey, folks.
Yes.
Trevor Spires here. I'm a solutions architect here at Amazon Web Services, and I am dialing in today from the spooky town of Salem, Massachusetts. We got a storied history here. If you haven't heard about it, ask your fifth grade teacher or Google it. But I'm coming from the real world, the real physical world. I see Forrest coming in from like some virtual AI generated oasis.
No way, man. This is my real office here. I've got all these plants. It's like, good for the air quality, and it makes it, makes me feel like I'm outside or something, right? Well, thanks, Trevor Dash. With that, my name's Forrest, and I'm coming in from the wonderful, great state of New York. Not New York City. I'm outside of the city ways. We have like apple orchards and trees and grass and stuff like that. So, yeah, it's pretty cool. Thanks for joining, everybody. We've made it. This is episode 4 of 4. That's right. I can count 1, 2, 3, 4. Implementing knowledge bases. That's what we're going to talk about today. Bedrocks, agents, all kinds of AI things. Right. Thanks for joining, friends.
Absolutely.
It's episode 4. Isn't this also our last episode of this series?
It is also our last episode of the series, which makes me a little sad, but I hope we're able to come back for more. Because how else would Dustin from Southern Indiana be able to see, our beautiful smiling faces?
Where you go to learn about agents in Southern Indiana? I'm sure there's a couple places, but this is a great place to start from anywhere.
I think that's the best place. Oh, and then Enrique wondering, where's Ivan? Ivan is not here today. In my brain, I fixed it immediately. I was going to say he's not with us today, but that makes it sound like something tragic happened. Ivan
is no longer with us, folks.
Ivan had a pre-planned vacation.
No, he swapped places with Trevor, right? We sent Trevor to the Bahamas via the Bedrock agents, told him to go there, and he couldn't find his way back. And so we actually sent Ivan to go find Trevor, but now we lost Ivan. So I don't. We got to work on fine-tuning our multi-agent orchestration workflows here a little bit. I think, guys.
Now Ivan can't find his way back. I think there's something that's drawing people in out in the Bahamas, and I think I should be the one to go find Ivan. Just saying.
I'm coming too. Next episode live from the Bahamas. That's where we're coming from, right?
Absolutely. And speaking of next episode and being live from the Bahamas, I want to know, is this your first episode, or even just the first time of you seeing a Twitch series hosted by AWS? But first, I just want to know for us, how many of our episodes in this series have you watched? Have you watched 1? Have you watched 2? Have you watched all 3 so far? Or have you never heard of us before?
Who are these guys? Dash?
Who are these people?
Why am I here?
and Eric, automatically, Eric is saying, hey, I don't know you, but we've known Eric for the past month already. Eric just wants us to think that we don't know who he is, but we see you through your computer, like the Matrix stuff. I don't know. Bad movie reference.
Any Matrix movie reference is a good movie reference in my book, Dash.
I agree. I was just looking for that validation. So So it looks like a few of you have watched all three so far, and I'm happy for you all to watch all three and this fourth one as well. Welcome back. I'm glad that you kept coming back. Again, this is our last episode, as seen here on our series page. As you can see, it is March 24th, 2020. We are at around 4:36 Pacific time. This is episode 4, all about implementing knowledge bases. We are going to have some knowledge base fun today. We're going to talk about them, talk about how to create them, and talk about all the different things that go into them so that you can actually go in and create your own knowledge base when this is over, if you so choose. The other really, really cool thing about our landing page is it goes to the different watch options. So we are broadcasting on LinkedIn, Twitch, Facebook, and YouTube. With LinkedIn and Twitch and Facebook as well, you will be able to go back and search for those other shows so you can rewatch the ones that you've missed so far if you have missed any of them. So the things that we've talked about on those other episodes, the first episode we talked about an agentic future where we explored different LLMs and their agents. We also talked about enterprise applications. You may have heard some use case stories from the 4 of us that were on the show that day. Forrest in the chat that day, and then Forrest on episode 2 moved to the limelight, came to the camera, where we talked about components of intelligent agents. We talked about the key
By the way,
components of
I
LLMs.
want to take credit for that. By the way, I'm the one who bailed on episode 2 last minute. So it is only because of me and my great decision making that you all got introduced to Forrest in episode 2. So
Wait a minute. I thought it was my stellar chat skills that everybody was like, we just need to see Forrest more because he's the man at the chat.
Yo, I think get a load of it. I think we traded up. Hold up. I think we traded up.
Whoa,
Tell me that's not a trade up, chat. Tell me this is not a huge trade up.
Welcome to my beautiful office. All these wonderful plants that I have growing here. We got the live clock on the wall over here. Let's see if I can do my weatherman skills. A little bit.
I just wonder how long you'll vamp as we keep the focus on the screen. All right.
Wait, no, I'm okay. Good. Bring your guys' self back. I was getting lonely up there.
Giving you enough.
I have that nice Winged Eagle Championship over there. It's not a clock, but I mean, you can wear it, I guess. We also talked about implementing some Amazon Bedrock agents again with Forrest because of Trevor. And now with both Forrest and Trevor, we talk about implementing some knowledge bases. But before we get into it, and before we start making some knowledge bases, I want to know whom of you did your home fund? How many people out there did the home fund? 1 for yes, 2 for no. I will say that I did do the home fund, mainly because I was forced to at work. I'm going through an exercise as a solutions architect where we're implementing some new Gen AI demos. So I was forced to do the home fund, but it wasn't really I was motivated even more to do the home fund, I should say.
That's a good framing. I like that. I was
motivated. Thank you.
I mean, all of this stuff with AI and agents, it's pretty darn fun, I mean, I find myself having to rip myself away from my desk to I should probably go hang out with my family and stuff instead of just hang out with the AI agents, It's like
I think they would enjoy that. I think they may enjoy that. So yes, so whether you created your own knowledge base, whether you built a RAG agent from scratch, hopefully you were able to do it. Hopefully it was successful. Make sure to tag us at hashtag home fund. That way we can see what you did and we can revel in your greatness. The same way that you try to revel in ours when we try to do something great, but we don't measure up to you all. hint, hint, wink, wink, give us validation. But
And everybody like these home fun assignments. We've had one each episode. Go back, check the previous episodes, and go through them. I think they're a really great hands-on projects. Build up your own little portfolio, and then they're also like if you have questions, reach out to us on LinkedIn, and we're happy to kind of point you in the right direction, give you some feedback on what we think about it, and just put our collective mind share together to help everybody create some really cool solutions. So.
Absolutely. And not to let this drag, but I think we should throw to Trevor to learn about some RAG.
Shall we?
That's today's topic. RAG.
RAG. R-A-G. Retrieval augmented. What's the G in RAG stand for, folks?
Greatness? Goodness?
Ooh.
Grapes?
Retrieval augmented grapes gets my vote, but in fact, it is. Oh, I see somebody tried it. They almost left off the G.
Yeah.
We'll give it to Enrique, who said generation G, which is like generation in Pig Latin, is what it sounds like to me. Iteration G.
Maybe we should just change it up.
I used to always say it wrong. RAG. I used to call it retrieval augmented. Doesn't matter anymore, folks. RAG's what we're talking about here. I personally like when I'm explaining RAG to customers, I like to just because for me, when I start talking about Gen AI applications, it can become fuzzy kind of quickly what's happening behind the scenes. So rather than try to explain it, verbally, which we will do plenty of times throughout this episode, I want to quickly scroll down and show you all a diagram. Let me get this open in its own separate.
Good looking diagram.
I love a simple diagram. I love a diagram that this is not a work of art. This is a clear engineering diagram. So let me explain what RAG is. First, RAG is, especially in the context of agents, because we're talking about agents, RAG is a technique that you can use to build agentic or non-agentic applications, specifically focused on enriching prompts or enriching the agent or whatever app you're building with data. LLMs, a mentor told me this, and it's always stuck with me. LLMs are really bad databases, all right? They're really good intelligence machines and understanding machines, but they are not databases. They do not store data consistently well. It's not something LLMs are good at. So in order to inject an LLM with your private data, you need a database, right? I almost envision almost like an application tier, database tier, where the LLM is that core logic, and then it needs to reach out to a database. So, but I'll dig into this full workflow here in a second. But let me start. I'll show you all a quick example. Okay, very simple
examples.
I've got a knowledge base, right? Which in Bedrock, we're going to dig all into knowledge bases today. We're going to drop some knowledge on knowledge bases, but I've got a knowledge base on Bedrock. I'm going to one nice thing about building knowledge bases on Bedrock, you can flip back and forth between models. This is on a model that was trained before Amazon announced its earnings on February 6th, right? But what if I wanted somehow this model to have in this application that I'm building on this model to have an understanding of what happened in Amazon's earning report on February 6th? With knowledge bases, you're able to do that. You're able to extend the model beyond what it's been trained on to ask some questions like, what launched? I even had a typo, but we'll see if the knowledge base is able to reply with what launched for me here.
I have terrible spelling, and it's been able to figure out what I've been trying to say most of the time.
Yeah. So here's all I wanted to show you all, folks. I asked it what launches. It was terribly typed, and it was able to start pulling information about what services launched and what things launched during that or that were included in that Q4 earnings statement that came out on February 6th, right? If I were to just go to the base model, in fact, let's go to the base model. Let's just ask it to show the kind of limitation that I'm talking about here. If I just go to Nova Pro and I ask it, I misspell it, what launches, my guess is it's going to say like a rocket ship or something, right? Yeah. See, it's saying rocket ships launch, products launch, businesses launch, but the model doesn't have the essential context I want it to have, which is, this document. And so now that concept of extending model knowledge, apply that to any kind of structured, semi-structured, or unstructured data that you may want to enrich your application with. That's what drives the usage of RAG, or retrieval augmented generation. Okay. To walk you through, any questions from the chat or from my co-host so far before I walk them through the kind of workflow of RAG?
I'm just learning. I'm just here to learn, just like everybody else, and so far, doing fantastic.
You're adding to our collective knowledge base, Trevor. I'm trying to download it all into my persistent storage layer right here. But so it's not my brain's not an S3 bucket though. It's not got like virtually unlimited capacity. So we're gonna use an LLM and a knowledge base to enhance what we can do and what we're capable of, right?
That's right. That's rightio. Indeed, folks.
Some good tie-ins.
So at a high level, what happens when you are using a RAG application is you'll send in your prompt, and you saw my two examples of what launched, one going straight to the FN, and then one going to really looking up knowledge that's in a document somewhere, right? So all that's really happening that when you leverage RAG, like after you send in a prompt, is there's some system, there's some what I would call like an orchestration layer, and that orchestration layer is in charge of sending that, basically doing a lookup in a knowledge base to see is there any similar data to the word launched, right? Or can I infer anything about this question, what launched, based on what's in that data? Then it's going to send back chunks of that data. So it's going to pull all the data that it thinks is most relevant from the database based on that query back into the orchestrator. And then the orchestrator is going to add that context to the prompt, so that way the LLM can effectively have direct access. That's kind of what it looks like from the user access experience, is like the LLM. It's almost as if you've plugged a hard drive into the LLM, and now it can access whatever data you stored in your knowledge base.
Yeah.
By the way, that isn't the case. The LLM actually doesn't have access to the data from a security perspective, but it will seem as if it does.
Yeah, I think it's a good way to so if we think about, like you gave the example earlier of the model being trained earlier, not having up-to-date information. And, one of the things that we do know about LLMs and generative AI in general is that there is the possibility for hallucinations in the model, right? Where we get back maybe not real information. So one of the ways that we can actually improve that and reduce those kind of hallucinations is by sort of giving it some like real knowledge, grounding it in some truth, maybe to be able to like, hey, okay, I can actually go out. The user asked this question. What was the earnings? I actually have a source of factual, up-to-date information. We can feed that in along with the prompt so that we can help reduce those hallucinations and really, fine-tune the responses that we get, right?
Yeah, I've even seen customers go so far as to say, like, in the context of a RAG application, like never, like they'll set up a policy that says never let the foundation model respond based on its training data. Only let it respond with data that's actually explicitly in my knowledge base or my database. So yeah, 100%. You can reduce hallucinations and also kind of like have these like a known good source of truth for the model responses in your application.
So grounding it in truth, grounding the model in truth is kind of really important to make sure you stay within those guidelines.
Kinda, for sure. I mean, absolutely. Yeah. I mean, I would say it's not just in general, like you've talked to customers, Dash. This is one of the things that comes up. Every customer who's just starting with Gen AI has seen some bad headline. I think the headline that was going around 4 months ago was like there was a car company that like said that they would sell a car for like $1 on the website when the car was really like tens of thousands of dollars or something like that.
Yeah.
That was a model hallucinating. That was a model giving incorrect responses to an information. And so that's, if you think about that problem, giving a customer incorrect information, a company could be held legally liable if it's not the correct information. Not to mention just like the bad headline, even if they can't be sued for it, just the bad headline associated with, hey, I just got, my bank to tell me that they can actually, do this thing that they're not supposed to do in the chatbot. Like there's all these reasons why it's really important to have some grounded source of truth within customers. And I would say like one thing that's interesting is like one of the questions that's coming up with more advanced customers, though, is not so much like, how do I prevent hallucinations? It's more like, when do I use a knowledge base versus when do I just call an API, right? When do I just call a tool? Kind of like we've been talking about over the last few episodes. And that's a more nuanced answer, actually. I wonder if folks in the chat have thoughts for like when you would use RAG versus when you would like call some API or call some tool as you're building an application. But there are some kind of key differences between those capabilities that you should.
And I know you weren't here, Trevor, but we kind of we go back to last episode where we were talking about agents and like multi-agent orchestration and things like that. So that was really what we were looking at in that last episode, is how do we actually go out and have those agents have an action that call an external API. Some of the examples that we gave were like a web search API, things like that. And you could almost think like, okay, that's kind of like a knowledge base, right?
Yeah.
But it's much more complex, right? I think with a knowledge base, or it's much more like, general purpose, if you will, when you're calling a web search API, right? Whereas a knowledge base is, hey, now we have like, it's our company documentation, and we can literally build a database that includes only the specific details that we need versus, maybe we need more real-time information. Like maybe we want weather data or something like that, right? I want the weather right now. That might be something that there's an already existing solution out there, and I can go call an API to return that kind of data, right?
100%. Yeah. That real time, because on the back end, you'll see today, I think we're going to build a knowledge base live today. Folks will kind of see like there's like a sync and there's like a scheduled sync. And so it can get somewhat real time, but it can't get real time when you might want an API. It also can't do things in the real world.
Yeah.
Like it can't trigger like it's a get function in a sense. Like you're doing a lookup in a vector database, but you can't necessarily like trigger some action. I can't order a pizza with RAG. That'd be a nice API you want to order a pizza from.
And inside of like say a knowledge base, a RAG model, it can also be more cost effective because it's going to limit the search to the things that are meant to be searched instead of everything that could possibly have to do with that prompt. So it's running less. It's making less query. Like it's searching just the things that are meant to be searched to respond to this prompt. And you also have the ability to kind of train it against certain prompts so that it, even if you put certain things in, it returns a certain thing. We'll get into that stuff.
I thought, and I won't get too far off track here, but I thought this kind of like was an interesting comment here from Hartstead. Is that, isn't the issue with putting safety rails in AI for business is that essentially becomes an FAQ more than a useful support agent? And I mean, I think that is like kind of something to consider, right? Like there's always these trade-offs between what do we really want to allow the machines to do? Do we really want to like become like the Matrix and have the machines totally take over? Or do we want to have some, that's where the human knowledge, I think, or human wisdom still comes into play, where we have to really think about what we're trying to accomplish. And there's going to be trade-offs on, safety versus capabilities and all of those things, right?
Yes, but it also depends on what the use case is. Like, for instance, if I want to create like an HR, knowledge-based bot where, someone can search, what are the providers that are available, for healthcare this year? that's still a support agent. Like, is it an FAQ? In a sense, but it's taking thousands and thousands of documents and it's going to comb
Oh,
through those things.
hold up though. I got a follow up, right? So this is where it takes it a step further, folks, right? Certainly I can do RAG and I can find out like what are my healthcare providers, but like, what if I were to ask, what if I already changed that prompt slightly? What if the prompt was, what healthcare plan did I have last year? Right? That's like, you have to think about these things as connected, because like, you're right. You could just build an FAQ RAG bot and maybe it's useful if like you have a lot of FAQs being asked, but real useful Gen AI applications tend to extend beyond just like being able to look up some RAG. Like asking a question about me, now you've got to inject my user ID into an API call and do an API call to that HR system Dash is talking about, or like my medical record system. And I think that's, to me, that's where it diverges from like, yeah, it could be a simple FAQ if you think building a support agent is throwing some documents in RAG and then walking away. But it's a little bit, there's more to it than just that.
Oh yeah. But
you have to
also,
combine all of those building blocks, right? Like you have to really make a fully functional, useful application. It's got to have a little bit of that FAQ component in it, but then it's also got to have that ability to go out and connect to APIs and pull in, what was your specific health plan, Trevor, and things like that, right?
I like this one. Yeah, this is where you'd put a guardrail on for that, right? Making sure user A can't query across to user B, that I can't prompt inject a user ID. But yeah, great.
And then also, like, you don't want, like, if we've built this healthcare agent, right? We don't want people using the healthcare agent to go ask for banking and stock details and start browsing the web, right? We have to have some sort of controls, right? Like you don't want to provide the general, AI, agentic AI. You want to have a specialized solution that's just for your customers, whoever they might be, right?
and speaking of, I mean, like, if we wanted to use RAG to maybe do some things like that, like, which which one of these options does RAG allow us to do? Uh, do any of these look familiar? Greenwire. Do any of these
Something maybe we
look
talked about before,
familiar? Think about copper and the green wire. Just what are we thinking? Can we craft chain of thought prompts? Is there going to be one correct answer here? Reduce the latency, ground the model in truth, reduce cost of hosting LLMs. What are we thinking? Okay.
What are we thinking, chat? Type of 1, 2, 3, or 4.
I see a 3. I see 3 popped up. I think someone remembers something about ground truth. All right. And I personally think you're absolutely correct. And now that we've kind of dove into that kind of space, I think we should learn about some RAG components. Forrest, can you help us out with that one?
Yeah. Let's actually take a look at what makes all of this stuff work, right? So we talked about, RAG, retrieval augmented generation. It is a key component in generative AI applications, right? But let's look at how this actually flows, right? So, again, here's a nice little diagram, like maybe if I can get my screen to move. There we go. That really walks us through what's happening, right? And so we have to start by gathering our data, right? We have to put that data into a database. We call this a vector database or a vector store, right? And then ultimately, user creates a prompt. The orchestrator asks, hey, let's go augment what the user is asking by adding in some data from our vector database, and then all of that gets combined and then sent to the LLM, right? And so it's really like adding that context to our prompt before feeding it in to the large language model and asking for a response, right? And I think if we're going to be designing these kind of applications, it's pretty helpful to understand how all of these different components work together, right? So I think, again, this is like a pretty good little example here that RAG, it's basically a 4-step process, right? The first step, you have to create that knowledge base, right? Create that collection of your internal data. Maybe it's your internal maybe it is the FAQ for how agents should respond to insurance and healthcare questions and things like that, right? So you got to create an embeddings database, right, where we ingest all of that internal documentation. And we call it an embeddings database. What we're really doing is we're taking, like, let's say all that text can actually even be like images and diagrams and other types of data as well. But we have to convert it into a format that the LLM knows what to do with, right? And so when I asked about, cats, it goes and knows that, hey, here's some other data in the database that's relevant or related to cats, right? So first of all, we create our database, our vector database, our vector store. And then a human submits a natural language question. We have an orchestrator that goes and then takes that natural language question and looks for data that's similar in that vector store, right? And then it returns, the orchestrator sends the user's query along with that context from the knowledge base to the LLM so that the LLM can generate a prediction, right? Or a response based on the question asked plus the actual data to generate that more fine-tuned or response based on your actual data, right? There's a whole list of different components that make all of this work, right? We'll kind of quickly run down through here and just so everybody gets an idea of how this flows, right? The connector, right? This is how we connect to our data source, right? So depending on where that data is, maybe it's a existing database, maybe it's a website, maybe it's a SaaS application. Think like your SharePoint site with all of your documents. We might be able to create a connector for to go in and extract the data out of that existing database, right? We have some data processing that we might need to do. This is really about preparing our data, right? Like data comes in all shapes and sizes and forms, right? PDFs, images, things like that. And we have to make sure that it's in a format that can be used by the model, right? Or by our application, right? Embeddings is how we convert that data into essentially a numeric format, right? We got to convert your documents so that we know when you ask about cats, here's other data about cats, basically, right? All of that goes into the vector database that lets us do that. The retriever, this is a component that, like, when the user asks a question, the retriever, just like your friendly golden retriever that continues to go and bring you the bone or the ball across the yard all day long. Well, we've got a retriever built into our AI application as well, right? So again, the retriever goes out, gathers that data, brings it back, and ultimately delivers it to the foundation model, right? The foundation model is your LLM. This is your Claudes, your Novas, and all the other LLMs out there that we love, right? And then we've talked a lot about guardrails, right? This is let's put some controls around it so that if we have that healthcare agent, we're not able to go ask the healthcare agent for Dash's big bank statement, right? Although I might try that. Dash can we get your bank statement from or maybe credit card number? That might be better.
If you got any of that information, it would only be for practice. There's nothing you could do with either one.
Yeah, same here. Mine wouldn't do anybody else really much good. So, anyways, and then the orchestrator, right? That's the Dash is kind of like our orchestrator today, right? He's the man with the puppet strings driving the ship for us, right? And then the user experience, right? That's like the UI. That's what we present to our users, right? That's an important piece of the puzzle, right? Is what does this look like? Maybe it's just a CLI interface, right? But Most of the time, our users expect a rich, web interface, modern design, with the ability to, look up past chats, display images, to give us that sort of user experience that we really want, right? Then we also have this kind of identity and user management side of a RAG application, right? We have to make sure that we're authorizing people that have the rights to use it and can get the right data and things like that. So I think long story short here is if we think about all of these components, it starts to get rather complex. And we have to actually, like, if we're building a generative AI application, we actually have to put all of these components together, right? And AWS has got your back, though, right? We have some fully managed solutions like Bedrock and Q for Business that we're going to look at more today that put all of these components together. I think that's really the story here, right?
That's a
Dash,
fact.
Trevor, what do you guys think?
That's a fact. I'd even say we got
on your own.
No, I mean, I've seen. So first of all, no, nobody's building these on their own. Guaranteed no. Like basically, you're using a managed service or you're using an open source framework. Nobody's building all of these on their own. I think it's that tends to be the question from customers. Do I use a managed service or do I use an open source framework? And yeah, I hate to break it to folks, but the answer is the same answer a solutions architect have for maybe half of the questions you ask us, which is it kind of depends. Kind of depends on your use case. Kind of depends on your current environment, the skill sets, the tools available. But I will tell you this: I've gone into customer environments that have started building out RAG with LangChain, which is a popular open source framework, and a lot of them will spend like weeks and weeks customizing, trying to get it to work in an eval or proof of concept in a way that is useful for them to like make a call of whether it's a good tool or not. And just the setup time involved in that is often one of the biggest blockers to doing an eval for something that you'll see in a few minutes on Bedrock. Like if you have an S3 bucket and you have an IAM role that can integrate with all the relevant services you need, you can have a retrieval augmented generation proof of concept off the ground in, a few minutes. It's pretty straightforward.
Yeah, pretty cool. Hey, Dash, I think hopefully everybody was following along with my monologue of talking about all of these bullet points. Should we quiz them and see what they think about this? What do you think?
I think we should. Now, technically, some of them did cheat and ask for the URL that you were using. It's not really cheating because we do offer it, and I did give it to them. But I'm going to guess that they aren't going to use it and that they're actually just going to go off, the old noggin. Go ahead. You want to read the question for us, Forrest?
Although I think it's fair to use their own retrieval augmented generation system that we've sort of got built into our heads, right? Right? But what do you think? Which RAG component might be responsible for storing our embeddings, right? And we ran through all of these different components. We've got, could it be the retriever? Does our friendly neighborhood golden retriever store our embeddings for us? Could it be that we store embeddings in a vector database? Or do they get stored in the foundation model? Or does our puppet master, the orchestrator, store our embedding for us?
I just want to shout out this answer here.
Definitely.
While I do not think it's correct, I do very much value it.
Days were simpler back then. Some Commodore 64s lying around.
Much simpler. Oh, but yeah, you all are correct. It is the good old vector database. Forrest, do you want to give them one more?
Yeah, let's keep it going. Let's keep it going.
Let's keep the party going.
Yeah. Which RAG component fetches the relevant context from the vector database and then also ranks the responses? Ooh, You know, could that be the retriever? Maybe like the retriever has like a red ball and a blue ball. Which one does it like better? You know, could the foundation model maybe do that for us? The orchestrator, or is that our embeddings? What does everybody think?
Oh, what are we thinking? It looks like we're getting ones in the chat. Looks like ones are the favorite here. We also see a 4. Also see someone that just in all caps retriever.
Yeah.
And really believe in that answer.
Very serious about it. Screaming retriever.
Oh yeah.
I
love it. I love it.
Lambda driver. I like this person's name, Lambda driver. We've got to play fetch. I feel like they've been around here before. You know.
I think so.
But yeah, there we go. It's the retriever. You know. Again, it's our. You know, you throw the ball out there, the retriever just keeps bringing it back. But if one of those balls is coated with bacon, I bet it's gonna rank that one higher and bring that back for you, right? You know.
I think so. I think that's a fair guess. I would say.
All right, friends.
All right.
Well, we talked about all of these different components, right? Like the components that make up this RAG. How do we? What's next? What is maybe a way that we could start building this on AWS without having to start from scratch, right? And do it all on our own, right?
Oh, how do we do that?
There might be a managed service, and there might be a managed service feature that helps you with exactly that. If I wanted to test out some RAG, first thing I would do is I'd log into AWS. I go to Bedrock. I'd spend a few minutes on the front page of Bedrock, clicking through all the fun models that are available, and I'd be like, "Wow, that's awesome! Bedrock's a cool platform that gives me a lot of different choices of models." And then I would probably realize, like, wait, hold up, what is all this on the left hand side over here? What is all this? These aren't models. What are these?
They're your toys.
They're your toys. This is your toolkit. All right.
Yes.
These are the tools that you need to build on top of all these fancy models. You know, in the conversation, it tends to start with the model. Hey, I want Anthropic. Hey, I want, this model. I want that model. Sure, fine. But once we get into actually building AI applications, Bedrock extends far beyond just giving you model access. In fact, it's going to give you the workbench to build an AI application like a knowledge base. Knowledge base is a simple way to quickly set up, query, and integrate with a vector store. In fact, I'll even say we've extended beyond just vector stores recently. I think we'll show you some of that as we set up the knowledge base here shortly. But the knowledge bases in Bedrock are a simple, managed way that you can test, iterate on, and even deploy into production a knowledge base with your AI application. So I'm not going to walk you through the full setup. I think we've got that for you here in the next stage of the show. Instead, I just want to kind of walk you through how they work at a high level so you can get a sense for why you might want to use something like this. And I'll even kind of draw the contrast in between the way knowledge bases work and the way, if you were to roll your own RAG, if you were to build your own RAG pipeline with like open source frameworks, how that might differ from something like knowledge bases. So first, I'll open diagram number 1 for you all. There's actually two phases of knowledge bases I want to walk you through. Let me open both of these for you. I'm going to start with the pre-processing phase. So like we're talking about RAG, retrieving documents, integrating data with your AI models. Before we can do all of that good stuff, we need to know where the data is coming from. We need to define a data source. Probably the easiest and most straightforward way to do this is to just dump a bunch of things that you want to run RAG on into an S3 bucket. That tends to be how I run my own tests. However, data sources might be an array of different things that are potentially loading data into an S3 bucket to be loaded into this upstream store, or it could even be some other data source. You load data into your preferred data source, or you point Bedrock knowledge bases at your preferred data source. And what's going to happen in a fully automated fashion is we're going to split that data into chunks. We're going to generate embeddings for those chunks and then load that into the vector database, right? So this process here, the process of getting data from your source and then formatting it correctly and then loading that into a vector database, this is fully automated by Bedrock knowledge bases. In fact, let me show you how fully automated it is, because it's so cool and fully automated. You're going to be like, wow, that was so automated and cool. I can't believe it's that cool and automated. If I just go into a knowledge base that I've built and I were to like, I'm just going to do this in the UI. Obviously, there's an API for this. But if I wanted to like load data into my knowledge base from Bedrock, I just click the sync button, right? And what's going to happen is as I click sync, the data in my sources are being copied into my vector database. Now, for those in the chat who haven't built a RAG application before, maybe haven't built RAG on something like LangChain, for example, this process of structuring your data, of chunking that data, of loading that data into a vector database, if you do this outside of a managed service, you're actually going to be building a lot of this on your own. So all of this automation that reads the documentation, that splits it into chunks, and you're going to be, of course, there are existing tools and frameworks that might read a PDF and allow you to like, pull data out of the PDF, but I'm talking you're writing Python code here, okay? Like that's how you would make this happen without knowledge bases. With knowledge bases, there of course are APIs, but there's also a really easy kind of quick start UI to just get something off the ground in the console. So right off the bat, just the kind of simple step of loading data into your vector database is simplified by knowledge bases and all of the great data source integrations that we have. But that's only half of it. Like that's only like half the level of effort is actually staging the data and then loading the data to the vector database. The rest is actually reading data from your vector database and then responding to the user, right? Knowledge bases also covers that part of the equation. In fact, there's a single API that you would call. It's called the Retrieve and Generate API that takes care of all of these steps, right? That actually will send in the query, retrieve the data from the knowledge base, and then generate a response based on that knowledge base. Where again, if you were building some type of RAG application yourself, you would have to be thinking about, which embedding model am I going to reference to perform the embeddings on my user query? You're going to have to integrate that with your upstream vector database. That's going to be, Postgres databases, some open source vector database. It could be OpenSearch, and then that summarizer and retrieval aspect is also something that you're going to build out in that. If you were building it yourself, you would kind of define all of these in code, where because it's a managed service, while all of this is being orchestrated behind the scenes, as a user of the application, you really just have to send queries in, and then all this entire kind of pipeline of embedding generation, retrieval, and response is automated by the Bedrock knowledge base orchestrator on the back end. So I think you'll see, as we show you the demos and kind of build it out with you, I think you'll see like the level of simplification that we're able to drive by really just taking a lot of the heavy lifting off of customers that are looking to build a RAG application, making it easy to get something up and off the ground to start testing.
Hey, Trevor, I think this is irrelevant. I know I saw Dash chatting about this too, but maybe you could help clarify this, right? Like, what's the difference between Bedrock knowledge bases and AWS Kyndra? Where does that fit into the mix here, right? I think maybe there's a little confusion on how those components kind of relate to each other. Right?
Totally. Yeah, I mean, there's a few ways to think of it. So first of all, Kyndra can actually be a data source for a knowledge base in Amazon Bedrock. So right off the bat, like if I'm already a Kyndra customer and I'm thinking like, wait, I've already invested all this time in Kyndra and all this energy in Kyndra, what happens to my Kyndra enterprise search? You can literally just make that up a source for a knowledge base and then now consume that through a RAG, basically a RAG-like application. I will say that, what's interesting about RAG in general is like, it used to be if you wanted something like enterprise search, you had to use or you would oftentimes use a tool like Kindra, or maybe some SaaS tool out there that you load a bunch of data into. And there's like there was quite a bit of science that went into like semantic search and searching behind the scenes, where now I would say it's almost like I would say just enterprise search has become kind of like democratized with RAG and generative AI, is what I would say, right? Meaning that the differences between the two is like they can do a lot of the same things. What RAG is like you can kind of plug and play your different components. You can use different data sources. It's a little bit more extensible than just plugging something into Kindra, I would say. I don't know. What are your thoughts? It's funny. I actually never worked on Kindra until after I started working on knowledge bases. So I don't have a lot of historic knowledge on Kindra.
Yeah, well, I think one thing what's important to I think understand here is that Kindra is a totally separate like enterprise search, indexing solution, right? And so that can become the index for your RAG application, right? That is the database behind your Bedrock knowledge base, right? So Bedrock knowledge base is the retrieval augmented generation managed solution that you can plug a whole collection of different embedding databases, vector stores into, right? And so you can plug in those vector stores like traditional, like there's an open search component that you can use. You can use custom vector stores. You can also use Kindra generative AI index as your data store for Bedrock knowledge bases. If that makes sense.
Yep. Yeah, exactly. Yeah. Kindra is a service that it can be like say your data store, your data source, I should say. Knowledge bases is a RAG application that you are building in conjunction with other data sources. So they are two separate things, but they can be joined as one in a holy union. Cool,
Yep.
cool.
Here's, I think everybody go take a look at this. I'll post the link in the chat here. The Kindra Gen AI index, right? And it's basically that a purpose-built a vector database for vector and search database for generative AI applications. Right?
Cool. All right. Now that we kind of got a nice little overview about knowledge bases, how would we configure one, Forrest?
Well, you would do it via the Bedrock console. Of course, there's an API too, but I think for demo purposes, doing it in the console, we can just kind of show you how it works. Actually, there's a couple of give me 1 second here. Let me pull up the right couple of links here. Here we go. I'll throw this up. So this is a pretty good blog post. This has actually been around for a while, but it's still actually relevant to give you kind of like the high level overview of how you would go about configuring your first knowledge base. But you start with that vector store. And then you have to give it a data set somewhere for it to index. And this blog will sort of walk you through how testing it. There's some examples of how to do it via the SDK here, just calling the APIs directly. So again, check this. We'll throw this link in the chat here, and folks can go try it on their own. There is also a publicly accessible knowledge bases and RAG workshop. And so if you've never gone through any of these AWS workshops, they are really pretty amazing, like step-by-step guidance on how to build like end-to-end solutions. A lot of times they'll have like, operational and monitoring and security related customizations in there. So this will allow you to do it all on your own in your own AWS environment. Keep in mind, though, that if you go through all of these, there could be some costs associated with them. Most of them will have like steps at the end to clean it up. So, but just keep that in mind. If you run this in your own AWS account, it could generate some costs. But most of the time, these workshops will document that. But this knowledge bases in RAG workshop will sort of talk you through building this whole end-to-end solution, right? And I think there's a little another nice little diagram that shows us what we're going to do. Creates this whole managed data ingestion workflow. New data comes in, that becomes a data source. We create that embeddings model so that we understand how those different pieces of the document are relative. That all gets creates what we call this vector store. And then again, here's that workflow, right? User asks a question, the retrieval maybe goes down and sends the query to the vector database, our knowledge base, says, hey, what data is similar to what was just asked? And then ultimately sends that whole payload over to the LLM, right? So go check this out. Maybe some of my fellow hosts here can drop the links into chat for everybody while we go through this, right? But let's actually just go over to Bedrock and maybe play around with it here. Let's oh, that's not what I wanted to do. But we'll go over here to the handy dandy Bedrock console, right? As Trevor was showing us earlier. And if we go down here, we can go right to a knowledge bases. And we're just going to go ahead. I have a couple set up already. We'll go through and create a new one. But they'll take a few minutes to provision. So then we'll go play around with the ones that I created. What was this? What would you call this style of demo, Dash? We were talking about this earlier, right?
Oh yeah. So we're gonna Rachel Ray it. So some of this stuff. Yeah, some of the stuff it takes a little longer for it to actually flesh out, for the demo to actually run to succession. So gonna put one in, show you how it's done, and then pull one out the oven that's already done.
There we go. All right, let's do it. All right. let's start cooking. Let's start cooking. All right, so knowledge base is cool. We're gonna just go ahead and create one. And you'll see there's actually a few different options. We can create a knowledge base with a vector store. We can create a knowledge base with structured data store. This is a more recent integration with Redshift. That's use your data warehouse as the knowledge base. Or we could create this Kindra generative AI index. Excuse me. For this one, we're going to go ahead and use this knowledge base with vector store. And we'll just call this the cooking show demo. I don't know why I'm calling it that. I don't have anything related to cooking. Rachel Ray. Maybe we'll call it the
meta.
Rachel Ray demo, right? We're gonna put this in the oven, right? We're just gonna leave some of these. What I really wanted to kind of show here was what are all the kind of pre-built data sources that we can connect to it out of the box, right? And so, really easily, let me zoom this in a little bit. And in fact, we can even get rid of this. I'll make it a little bit bigger for folks, right? So S3, right? Simple, right? We can have all of our data, like all of our, maybe all of our, cooking recipes are stored in S3 somewhere, right? That might be a good thing to use. That's a great way to get started. But there's also built in some third-party connectors. Confluence, you can plug right into Confluence. You can plug right into Salesforce. You can plug right into SharePoint. So super easy to integrate.
Now that is cool, because I know a lot of customers that use either Confluence or SharePoint for like most of their enterprise data. I'd say like a lot of traditional enterprises are really heavy on SharePoint for like most of their kind of typical doc and enterprise search. And like Confluence, it's like I feel like almost every startup I work with, like everything has been standardized on Confluence like that. That's very cool to see.
You can imagine like a new engineer, new employee comes in, and like the way we used to do this was like, here, go to the Confluence blade, go to the SharePoint site, start searching through it, finding what you need. That's pretty inefficient, right? Like now if we have a retrieval augmented generation AI chat application integrated into our Confluence documentation, now that new engineer gets ramped up faster. all that stuff. And it's super easy to build these kind of custom solutions, right?
The SharePoint one actually helped me with the customer this week, and it's Tuesday. So
yeah. Yeah. Wait, no, is it? Wait, no, it's not Tuesday yet, Dash. Today's only Monday.
Oh, it's Monday. Wow, was I working on Sunday? I don't know what happened. I need a nap.
Yes, yeah. So do I. Time is sort of blurring together. Anyways, some of the ones that I think are really cool that like make this even easier to like build, to get started with, is this web crawler feature. Like you can literally just point this at your own web server, right? Like you need to own the web server. You don't want to just be like crawling everybody's web servers out there, right? But there's a built-in web crawler connector. There's custom, right? You can create your own custom data source. Actually, I'm gonna
on the web crawler real quick, just because I want to point that out. Everybody wants to test the web crawler first. So if you're testing this at home, just remember the web crawler does respect robot.txt. So like just because you point it at a web page does not mean it will actually crawl the web page. The web page might have said, please don't crawl me. So just FYI, that's maybe the most common like error I see people trying to test KBs and the web crawler is not working.
I'm just gonna go start indexing everything out there on the web, and if it's a well designed web solution, then the Kindred or the web crawler here is going to obey those rules of the internet, essentially, if you will, right? But I actually like clicking on the custom one here and just going next, and there's you basically can create your own fully customized how it looks at the documents. You can integrate it with Lambda functions. You can there's all kinds of other like open source third-party serverless vector databases that you can use to integrate with as well. I just kind of wanted to show that. But what we're going to do here for our Rachel Ray demo. Oh man, it changed the name. Didn't save it for me when I hit back. Rachel Ray demo. We are gonna go. I am gonna choose the web crawler one, just because it's sort of one of the faster ones to set up here, right? And we're gonna go next, and we're gonna say, web crawler. And right here, we can literally just put in whatever we want to search for, right? Or whatever, any web URL as the source. You can add up to 9 different URLs. There's some, you can and have it encrypt the data. You can decide how long you want it to store the data. You can choose how deep you want it to search, right? So do I only want to look at like the top level domain? Do I only want to look at that one specific host? I want to also look for through subdomains. If you leave it on default, right, it just looks at like a seed URL of, let's say, like AWS.Amazon.com/bedrock, and then only that path. So bedrock/anything will be crawled with that default setting, right? Whereas things like without bedrock are not going to be crawled, but you can change and customize that, right? And so I think for the fun of it, why don't we just actually see if we can have it crawl our Bedrock agents page just like it gives in the example here, right? We'll go up here and put this in as our source URL. We're going to leave all the rest of this default. We'll just leave it on the default. We don't want it to crawl other things like EC2, for example, right? We can kind of customize the crawling speed. All this is going to be really important. What you should be doing is not going out and crawling public documentation, right? Like this is purpose built to be crawling your custom, your customer owned documentation, right? You're building that health search application inside for your business. And so you're going to point it at your company web servers, right? Supports regex filters. So you can really get customized about which URLs it actually ultimately goes out there and crawls, right? Another important component here is this kind of chunking and parsing strategy. And this is sort of like the data preparation and how is it actually going to like store that data in your knowledge base. And so there's kind of like a default Bedrock parser. It actually works really good, no additional cost. But there's some other things that we can do here, right? Like if we have, let's say, visually rich document and images, then this Bedrock data augmentation parser can actually do that, right? And as well as this foundation model as a parser. These let you basically use another LLM to go and sort of analyze the web crawl data, determine what parts of it should store, right? The default one is just going to look at the text, right? If you imagine websites today, they've got pictures and images and dynamic components. And so we might want to actually pass it through another model to sort of analyze that, determine what it actually stores in the database, right? So we'll leave it on the default one. Again, you can choose some different chunking strategies, like how many blocks of text it essentially stores together, right? Like if you had a 10,000 page document, you don't want that 10,000 page document to be all stored as one chunk. Every time somebody asks a question, we feed that whole 10,000 page document into the LLM, right? This is how many words essentially. You can kind of think of that. We want to break it up into smaller chunks, right? So we'll go ahead and add that. Embeddings model. This is, what is it going to do? What predefined model is it going to use to, once it's analyzed it, to convert all of that text into essentially data, numbers that it can reference, right? And now can look for things that are similar. And there's a few different ones that you can use. We're just going to choose this Titan text embeddings model. I'll use that one. And this is, again, where we want to load all of that data that after we've crawled it, right? We're going to create our own a new vector store. We have one already, maybe we already have, a Kendra search index. We could actually use that as well, right? But we're just going to do this quick create. It's going to create an open search serverless environment for us. And we'll go next. Here's our Rachel Ray demo web crawler, and we'll create the knowledge base, right? And so this does take a few minutes to fully spin up, but maybe we'll come back to it and see what it does. For now, though, let's see if we can open up our pre-baked cake and pull it right out of the oven. All right. We go down here to our knowledge base, and here we have this web crawler. I should have called this one the pre-baked cake, right? But this is one I set up very much the same. My data source is, if we take a look at this data source, I put in the URL. Where does it show the? Anyways, I put in the URL for our what is retrieval augmented generation web page that we were looking at earlier, right? And so we can now that it has this data, we can actually go in here and, well, first of all, we have to pick which LLM we actually want to use to answer our question. This is a pretty good way to like compare different models. And so let's try out Nova Pro. And we'll ask Nova Pro now, what is RAG? And here we go, right? It spits out a whole bunch of information based on the retrieved results. RAG stands for Retrieval Augmented Generation. LLM, the external data, such as a company's internal documents. Hey, that sounds pretty correct. And the thing that's pretty cool about this is that it actually adds in here little references to where it actually found that documentation, right? Where in your knowledge base it actually came from. So you can validate, oh, yeah, cool, right? Came from this Amazon.com prescriptive guidance page, right? And here's a little chunk of the data that it used. We can actually expand this out, and it will show you what your query looked like. And this is the source. This is it looked in that that embeddings database to find things that were similar to my question, right? And it found this chunk, and that's what it used in its request to the LLM, right? And you can see actually there's a whole bunch of other chunks that it found here as well. And these are all just pieces of text from that web page that it was able to crawl and index for us, right? One thing else I wanted to show here is so we can add actually multiple data sources to this knowledge base, right? Go back down here again. Ooh, my Rachel Ray is now available, but let's go back into this one here for a second. And we can see I actually have two data sources. What is RAG and S3? And so if I were to ask the same model, what is S3, right? It told me what RAG was because it had that data. This is actually going to tell me that it doesn't know what S3 is, right? Or it's going to say that based on the retrieved results, S3 is not explicitly defined. And again, remember, this is a kind of a specialized interface to test our knowledge base, right? And so it's set up to only ask the knowledge base for things, right? It says it's a likely an abbreviation for simple storage service. So I was able to sort of figure it out, but it didn't have that data in its database. And that's because while I added S3 data to it, oh, here's the, that's what I was showing you. I added the documentation page for the S3 user guide to this. I did not actually synchronize it, right? Hasn't been synced. So we do need to do that, right? Synchronize our data source. And you could set this stuff up to happen automatically, obviously, right? And so, but if you're testing it, you create your data source, and you're like, wait, it's not working. Well, make sure you go in there and sync it, right?
Cool.
Right.
And with going through that, I feel like there may be a question or two that may be useful to go through. Forrest, did you
I think we
mind?
got some. Like, were people following along? Again with my long monologue there of knowledge-based things. What do people think? Right? What did we talk about? Which vector stores do the Bedrock knowledge bases support? What did we look at? We talked about a couple of different options for vector stores in Bedrock knowledge bases. Could it have been OpenSearch serverless? Was there Amazon Neptune, DynamoDB, Redshift?
What are we thinking?
This is I feel like this is a little bit of a tricky question, right? There's actually
the key point of this one is vector store. There are vector stores, there are indexes, and then there are also what's the third one that one of these services allows?
There's like a structured data sources, right?
Structured. One of these is structured. Two of these are vectors, and then one is just completely unstructured.
Yep.
So what are we thinking? What are we thinking? I see a 1 and 2 coming in from YouTube.
1 and 2.
I'll go ahead and I'll add those
and
for our YouTube folks.
There we go. Yeah.
So for this one specifically for vector, we are looking at 1 and 2.
Excuse me.
All right. But there may be another question that adds a little redemption in there. What are we thinking?
Which data sources? So remember, I know we went through all of this a lot, right? We got a data source. We're going to get some data, and we have to load it into a database or a search index so that our agent, our knowledge base, can go and retrieve the data out of it, right? You can't just have a bunch of collection of documents. We have to have a way so that we know we have to have a way to search it, right? And so which data sources might we load into our vector store, right?
So coming in from YouTube, I see a 1 and a 4. What else are we thinking? Anything different?
I see some 3s sprinkled in there.
See that 3. SL did the 3, the 1, 3, and the 1 and 4. I think SL might have changed the answer. All right. So for this one, the different data source types are in fact web crawler and Salesforce. Oh, nice. I also want to show one more thing. And the thing that I'm going to talk about, the last thing that we're covered today, before we wrap up the episode, is evaluations. So in order to do an evaluation, there are some things you have to set up first. First, of course, you have an active AWS account. You're going to select an evaluator and generate the models for Bedrock. You're going to give it access. You're going to make sure that the things that you're working with are all in the same region. This is a key thing here. You want to make sure that there are the permissions given, that everything can talk to each other. Even in AWS, the services need permission to talk to the other services. And you need to set up and enable cores. So here, I actually have a document that shows us how to enable cores. So we're just going to go to that S3 bucket. And you can copy and paste this here into your cores section. So if I go over to, let's say, for instance, this KB eval test dash bucket, I don't know, crazy name. Why is that there? We don't know. And then I go over to permissions and I scroll down a bit. Here under cores is where I would paste that in. Now, this is a very generic, like minimal level security of what you actually need to enable cores. But you can make this as locked down as you need to. This does need to be enabled in the bucket the buckets too that you are using in order to actually get this to work. And then once we take care of those prereqs, we're going to prepare the data set. We can have a maximum of 1,000 conversations per job, maximum of 5 turns. It has to be a JSON-L format. I'll show you what that is. And then we can start to put in those prompts. Okay, Dash, you said a lot of stuff. What does any of that actually mean? I'm glad you asked. When we are in Bedrock, let's say we want to run evaluations on the bucket itself so that we can either train it to give the responses that we want it to give, or see if we give it some pre-baked prompts, what types of answers it will give, and kind of give a score based on that. So I'll go to evaluations. And in this instance, I'm going to go to RAG because we're talking about RAG, knowledge bases today. And I'm going to create. I'm going to give it an evaluation name. This name is perfectly fine. I can give it a description. I need to select the model. So here I'm going to go to Anthropic and I'll pick the Haiku. Then I'm going to go to my inference source. This is going to be a database. Which database am I going to use? I'm going to use this database, a database that I've already created. And if you want to know what this database does, I can tell you. It is going to tell us about these Pixar movies. In my database, I put together this, I uploaded this CSV file that just tells me about the different Pixar movies. I love Pixar. Pixar's been good to me. I'm going to do both retrieval and response generation in that actual document itself. This one here It's going to let us know what actually happens when we pick either the retrieval or the retrieval and response. And basically, again, we're just going through the steps to create this so that it can give us some information on whether or not these prompts are going to give us the answers that we're expecting. I can select which metrics I want it to test. So we'll just go ahead and click everything here. We're going to click everything. We're going to be happy. Stereotyping, harmfulness, refusal, citation precision, correctness, helpfulness, completeness, everything. This is where the chorus comes in. I have to pick the data sets. This S3 URL is going to be that JSON-L file. This is my example of that JSON-L file, and I'll make this bigger so we can see. I'm going to put in the conversation turn, the prompt. I'm going to basically have some prompts based on the data set that I'm uploading. So what year was Monsters, Inc. released? That's a decent prompt for us because I have Monsters, Inc. here, and I have the release date. So I want to see how it's going to give me an answer and if it's as close to Monsters, Inc. was released in 2001. Same thing, this one. What movie has a toy called Forky? Toy Story 4. How am I getting the information? Easy, because in Toy Story 4, here, there's a new toy called Forky. So I'm going to use all this information, run it against my knowledge base that I built up and uploaded that file of S3 to see how it works. I'm going to browse. I'm going to go to my KB eval test bucket, and I'm going to pick that JSON-L file. I'm going to hit choose. Then I'm going to go to the results for evaluation. I created a folder within that same bucket where it's going to load those eval results for me. Hit choose. Also need to pick a role. I can use an existing role, or I can have it create a role that's going to have the minimum permissions for me. And I hit create. And it's now creating for me. While it's going and it's creating and it's doing its thing, it's going to run for 10 to 15 minutes. Bare minimum. It can run up to hours depending on how big the data set is.
Do we have a Rachel Ray of this one?
We have a Rachel Ray of this one.
We need a Rachel Ray because we got a few more minutes left and we gotta bounce on. So let's Rachel Ray it up and show these folks.
I'm gonna Rachel Ray this. All right. So when we go to the Rachel Ray, we can see here that one was already done. And it gives me an answer to all the questions that I want. For correctness, it's a 1. For helpfulness, a 0.83. For faithfulness, a 1. I can scroll down. I can get bar graphs. I can even compare multiple evaluations to each other if I want. It will give me sample conversations. Well, it will actually say, and I can expand this, the conversation it had, the generation output, and the ground truth. The ground truth is the thing that I told it that I wanted it to say. So it said it was released in 2001. This one says released 2001. Another question I had, the film rating for Incredibles is PG is what it kicked out. The film rating is PG is what I wanted it to say. I'm lessening the amount of tokens that it takes to give the response so that I can save a little money. So this is what the evaluation is. I get to have a JSON-L file where I give it some prompts, give it the responses that I want, run it against the model, and it compares what it actually got to what I wanted to try to train it up to get the responses that I want.
Yeah, I mean, I think this is super powerful. I mean, we talked about a lot of stuff today, right? All of these different components and how all this gets put together. And then at the end of the day, how do you figure out, all right, does all this that I put together doing what I want it to do? Well, there you go, right? Like built-in evaluation tool. And I think this is something that as people build more and more AI-based applications, it's going to get more and more important to start evaluating, hey, when I turn this little knob, how does that affect my result, right?
Exactly. And this is something that actually just went GA, just made generally available last week. So this is a rather new feature that we have that, again, it's just allowing us to continue our AI journey and make sure that we can train our models, even our RAG models, fine tune them to the ways that we want. But with that being said, Trevor unfortunately was right. We are coming to an end of the series of the episode. Have a few call to actions for you all. One, go out there, continue to build. If you haven't done the home fun already, do the home fun and tag us. Also, go back and do some of the home funs again. And as you learn new things, let us know. Continue to share the knowledge. You can also go out and follow all of us on our social medias. We'll put our LinkedIn's in the chat. Trevor also has a YouTube channel as well. Feel free to follow Trevor's YouTube channel. And before we close, Trevor, Forrest, do you have anything you want to say?
No, just come join us again. We'd love if you like to see if you liked what you saw here and you'd like to see more, let us know, and we'll happy to would love to do this again. Right? We can always dive deeper into this stuff.
Absolutely.
So thanks for joining, everybody. It's been a blast.
It has been a blast indeed. I got nothing better to say than that, folks. It's been a pleasure for the 2 weeks I was here. Thanks a lot for the awesome engagement, and I guess we'll see you on one of these here streams in the future.
Absolutely. So yeah, as we close out, just want to say, make sure that you're kind to yourself. Make sure that you're kind to others. Hopefully, we're able to see you down the road sometime, whether it be in person or this virtual platform. And until then, we'll see you again.